All right, so in R3, our R is given as x0 plus at, y0 plus bt, and z0 plus ct. R prime, the derivative, is just going to be abc, and its magnitude is going to be the square root of a squared plus b squared plus c squared. Now here is where we get 0 immediately. Well, not yet. We create the tangent vector first. The tangent vector is abc divided by the square root of a squared plus b squared plus c squared. Now, the whole thing is just constants, right? There are no t's anywhere. Constant. So when I find the derivative of t prime is 0, 0, 0. So curvature of t is going to be vector 0, 0, 0 divided by the square root of a squared plus b squared plus c squared. And now these are that's the magnitude up there. The magnitude of 0 vector is 0 divided by the square root is 0. So curvature is 0. The curvature of the straight line is 0, which is common sense. They also give you the alternative formula of a curvature using the cross product. We're just going to walk away from that one. Because why would you use cross product with 15 pages of calculations attached to it, right? Or maybe you want to. I see 3 faces shaking yes. Okay. Alt formula. And I'm not going to put the exam question to be use the alternate formula for curvature to compute. No, because such is life. So velocity times the acceleration, cross acceleration, divided by velocity cubed. Might help you with some homework exercises, but That's about it. Principal unit normal vector. Principal unit normal vector. So this concept shows which way curvature turns. When you say that the curvature of something is 5, well, you don't know whether it turns 5 this way or it turns 5. Unit normal vector will point either up or down. Okay, it just crashed. Let's see if it works. So for curvature K1, we're going to have the unit normal vector N1, and for curvature K2, we'll have the unit normal vector N2. So starting from the same point, curvature of, let's say, 5, right, can go either of these directions. And the normal vector is actually the one that shows which way, because these normal vectors are everywhere. Normal vector is perpendicular to the curvature and it points inwards towards the radius. Just like the acceleration for acceleration, but then we are going to calculate it with the dt parametrization. So definition for the unit normal vector, principal unit normal vector, let R describe a smooth parametricized curve by arc length. So let R describe smooth parametricized the principal unit normal vector at point P on the curve at curvature is not 0 is given by the formula n hat s is equal to dt ds divided by ds divided by the magnitude, right? It's a normal vector. So you take the derivative of the tangent to get the normal vector, and then you divide it by its magnitude because you want a unit vector there. So that works out to be 1 of the curvature times dt, these are all unit vectors here, ds. Now again, this is the definition. We want the formula. So formula would be, when you replace this ds, you use the same concept to switch like earlier. So now you get that normal unit vector in t is given as t prime of t divided by the magnitude of t prime. And this is the formula to use to compute, to find that vector. Now, in general, the calculations for normal vector are good for two things. One is killing time, and the other one developing carpal tunnel if you don't have one. So, what do we have, an hour? Let's do one of these. We need r, then we need r prime, then we need t, then we need derivative of t, and we need the magnitude of the derivative of t, and we put all of that together. Yeah. Welcome to Calc3. Concepts, Joe. Calculations, ow, right? So let's see. Let's find one of the. Let's see how good your homework is. How creative your homework is. And you better appreciate me going through the whole calculation for absolutely no reason. I want to see flowers, cakes, and thank you notes. All of it.